In this next section of Chapter 4, we'll learn how to create a new data set using a set command or modify an existing data set. So let's review a few things first. How many ways can we create a data set? What we saw first in Data Step Information 1, Chapter 2, that was using a data statement where we name the data set, followed by an input statement where we name each of the variables, and we identify each character variable with a $sign following the name of that variable in the input line, and that was the only place we used that $sign, and then followed by a data line statement. So more succinctly, data input data lines. That was our first method for creating a data set. Our second method for creating a data set was using an output statement, and the output statement was an optional statement that was available in the univariate procedure and the means procedure. And that output statement, then we named a new data set, so it was output out equals new data set name, and that new data set contained summary statistics that we specified from either the univariate or the means procedure. Then in Data Step Information 2, where we're at now, we've learned that within that data input data line sequence of statements, we can insert after the input statement and before the data line statement new variable assignment statements following the SAS naming conventions for variables. So that is new variable name equals an arithmetic function of numbers, an arithmetic function of existing variables, or some other SAS function of variables that already exist in the data set. We also saw a constant function such as that when we created state equals OK in quotation marks, meaning the Oklahoma abbreviation, but it was text. And then we've looked at if-then statements. So if-then, the action taken in the then part of those if-then statements could be to create a new data set, or pardon me, a new variable within the data set. But now we know that SAS holds these data sets, whether created in a data input data line sequence or an output statement. SAS holds those data set names in memory for that entire SAS session until I write over it. So now then we want to look at two new commands coming up in Chapter 4. The first is the set statement. The set statement can be used to modify an existing data set. The set statement must be used in a data step. So that is, there will be a data line, a data statement before it, and then a set command. So in this first option, we look at modifying an existing data set. In modifying the existing data set, we pick a new SAS data set name following SAS naming conventions, and then we use a set statement, old name. Okay, so whatever name exists previously in this SAS session is what I mean by old name. And so this will bring in the old data set, we give it a new name, and then we specify some new data step operations. So these could be, again, if-then statements, new variable assignment statements. Okay, and so that we can modify that old name data set with these data step operations. So the things to look for here, or notice here, is that this is just data statement and set. There is no input statement, there is no data line statement. It's just the data statement and the set statement. And then the set statement, after following it, then we can put our modifications. So if we look at some options to do this, we'll look at this first one in our first objective. So the first objective for the set command is objective 4.7. And in this it says to create a new SAS data set containing only the data for the male specimens in the SAS data set fish. So going back to where we left off earlier in the chapter with our data set fish, we had a conversion to length in inches, we corrected gender, we added a state information, and we corrected the location so that it was proper case. And this was our brief data set. So now then, if we wish to keep only the males in a new SAS data set, well, I'm choosing a name here that makes sense to me, so males underscore fish. So recall, for the names of the data set, the underscore is the only special symbol we can put in a SAS dataset name or in a variable. And it says go get the existing dataset fish. We're going to call the new dataset males, and so then we'll just use an if gender equals female, then delete. So I cautioned you earlier, it's like be careful about just deleting things, lines from the data, unless you're certain they should be deleted. In this case, the dataset fish is left intact. It's the dataset males that's being affected by this if then delete action, and this is objective 4.7. So if we run this, notice all I have is a data fish and a data for males fish. There's no procedure in here generating printed output. Okay, so if we run this, and then I also see over here to the left I have objective 4.6 still here, and so anything that's in the log or in the results viewer, let's just go ahead and clean that up and remove all titles and footnotes at the same time. So we can see that this reset, the results viewer, there's nothing here because again we didn't ask for any printed output here. What did we ask for? So for the data males fish, if I go through all of this, I can my work.fish has 6 observations and 8 variables. So I didn't change the number of variables here. I just asked it to keep only those that were males in this data set, and so that there were 6 observations read from the original data set. Males underscore fish has 2 observations and 8 variables. And again, we've kept this data set small, so that's a real easy check. Male 1 and male 2. Okay, so that's one of the ways then you can modify an existing data set, is if you change the name. There are other instances when you may wish to keep the original name of the data set, and so you could put data fish and set fish and not change things, and that's what we look at in objective 4.8. In objective 4.8, we're to add the additional variable species to the SAS dataset fish that we saw in objective 4.5, which is what we have up above here. We want to use the set command for this modification. So we're going to set the species value equal to darter, all in lowercase, for all observations, and then we want to print only the ID, locations, species, and weight in that order. We could have gone back and just modified the code in objective 4.5, but to keep each of our objectives separate, then I have new information here. So this says get the existing dataset fish, set fish, get the existing dataset fish, and we're just going to write over it on top of it. And the addition we're going to make is that it's going to have the species equals darter, and then we want to print it. Okay, and you see objective 4.9 is kind of peeking down here in the bottom. We'll get there in just a little bit. So if I just highlight this information and run it, when we go to the log, it says data fish, set fish. So the first line refers to the set command. It went and got data set fish, which we knew previously had 8 variables. Now you'll see that in the new dataset fish we still have 6 observations, but we added a variable for species, and then we printed that information. And you can move to the results viewer, or you can click over here and it generates that. And so we requested the ID, the location, species, and weight in that order, and so you can see the effects of adding species in this objective. In addition to modifying an existing data set, the set command can be used to vertically concatenate or stack data sets. So it's generally the case that the data sets being concatenated vertically have one or more variables in common, usually more than one variable in common. So that way that those variables that are in common will line up under each other when we look at a printed list of those. And so that we want to be certain then that the variable names are spelled exactly the same way. So in the dataset fish, I have ID, location, length, weight, age, gender, length in inches, and state, and then I don't have to repeat location and gender and location, because those were in the initial input statement. So that's how I count how many variables I have. And so just take note of how they are spelled. So this data set came from Payne County and in the state of Oklahoma. So in Objective 4.9, we have another data set. I have to have a different name for it than just fish. So here, fish underscore Noble, indicating Noble County. The input statement here, I have lake information, gender, weight, length, age. So that input statement looks quite different than the input statement on the original fish data set, and that's okay. Notice they both have ID. They both have gender, weight, length, age, but probably in a different order. Okay, and then we also notice then length in inches is added because it has the length in millimeters as we saw before. Gender, we did a lowercase correction in the Payne County data, so I've got it here, although it doesn't look like it's going to be needed. Location, this time the location is Noble, and the correct spelling there. So notice location wasn't in the input statement up here. So I have to supply location. In the previous data set, location was in the input statement, and still state of Oklahoma. So we just have some different content. A lot of it's the same, but if you wish to combine those, so I just chose a data set name that is the word combine. You can choose anything you want as long as it adheres to SAS naming conventions. The original data set fish and fish Noble are the two things listed in the set command. So this says then that sort of if we think about things getting stacked one on top of the other, fish is at the top and the second one in the list will be fish Noble, and then we can print what that looks like. Then you can also work on any combination, on any procedure for the data set combine for each location. The locations then being the different county names within the state of Oklahoma. No variable statement is used here, and all the numeric variables will be summarized then, so that if we look at this new information, so data for the fish Noble, the combine, and then the analysis, submit this code. We can see that the list grows here. Go to our log, we saw that we have output. So we want to make sure that when we look at our recently submitted lines, we don't have any errors or warnings. So here in the combine, one more, we had 5 observations and 9 variables here. And so that it names off for our set command here both of the data sets, how many observations they have. In there's going to be 11 observations altogether and 10 variables. So we're not sure here about, well, why 10 when we had 9 here to start with. So we'll look at that. And then let's print that information. So if we move to the output or the results viewer, the printed output is up here. And what we notice here is that for the Payne County information, Payne has been corrected, such as we did back in Objective 4.5, I believe. The species darter has been added, and to Payne County, however, Noble County didn't have a species. If you look at the fish Noble, nowhere in the input statement or on any of the new variable assignment statements was there information about species. Okay. Also, Noble County had lake information given by these shortened names here for 2 different lakes in Noble County. And so if we go back to the program for a moment, also notice we had lake here. When we talked about lake with the dataset fish from Payne County, that lake information, however, was in table 4.4, and if you recall, in table 4.4 we didn't actually run that code because there were so many if-then statements there. That would cause some logic errors or whatever, so we never ran that information in table 4.4. But we do have a lake information here that we didn't have ever created in a data set formally in Payne County. Now we know how to do that, of course, and we could have go back and modify our initial fish data set to do that. Now notice this lake information is last. It was the second variable in the Noble data set, and if we would have just printed Noble, it would have been over here. Okay, but the order of the variables here follow the order of the variables in the fish data set. Okay, and the reason I can control the order, of course, in the proc print, I can put a VAR statement and control the order of the variables, but this just lets me see what the default order is. So that's why Lake appears last here. Now, could we have stacked Noble first and then Pain? Certainly. And in that case, then this Lake information would be back over here before Noble. And Noble, recall, is actually created second to last here. So there would be quite a bit of change up in the way these columns would be ordered if we would have chosen to put the fish Noble first. The means we looked at for the combined data set for each location or county. If I use a class statement, recall we don't have to sort by a class variable, and so we have Noble first and Pain second, even though they were put in the different order, because the class statement is alphabetizing those. And so it gave me the summary information, the default summary statistics the means procedure generates. It gave me those for ID, length, weight, age, and length in inches, and it's the same list in the means procedure. Pardon me, and for Payne County in the means procedure. ID, having an average ID doesn't make any sense here, but if we didn't want that information, then we would need to put a VAR statement in the means procedure and specify exactly which variables that we would want analyzed. An additional caution here to be careful when you create the second data set, second or later data set, if you would have put in some other abbreviation, say WT for weight or just L for length, or had some other kind of a Lake ID, anyway, your variable names are different. If you have, say, for example, weight in both data sets, but you don't name them the same name, so variable weight in the fish data, initial fish data set is the word weight spelled out, and in the second data set it's given an abbreviation WT, then those are going to be recognized as two different variables. And whenever you look at the printed results, then here you're going to have weight given for Payne County, and then you would have WT as a different variable for all those in Noble County. So you'd want to make certain then whenever you start concatenating things vertically that variables in this data set that are indeed the same as the other data set that you're choosing to concatenate these results to, that those variable names are spelled the same way. Okay, they don't have to be in the same order, but they do have to be spelled the same way. So be careful or be attentive to special characters. If you've put a $sign on a variable that was numeric in one, say for ID, that could cause some problems there as well. A second method for combining data sets is to merge two data sets. So if the set command concatenates things vertically, merge concatenates things side by side. So that is the way to think about this, is that perhaps you have multiple data sets and each data set has something in common. They have a subject, some common responses, or some common ID, such that you can link the lines of information in one data set with the lines of information in the other. That's important. And so we have to look at what those variables in common are, and that each of the data sets then to be merged are to be sorted by that key variable that they have in common. So that could be one or more variables. The by statements here for these two illustrated data sets here in this example SAS syntax, they must be sorted in the same way. And then whenever you look at the data set, you create a new data set, you merge data sets A and B, and then you merge them by the variable list that they have in common, and they've already been sorted and put in that order. So this is the idea that you're going to grow a data set in the number of columns. Now you may end up with some unique rows in data set A that don't have any corresponding elements or observations in data set B, and vice versa. So it can grow in number of observations, but the intent is to create one data set such that you grow in the number of columns or variables. Previously, we had a data set called grades that had a student name, ID, exams 1, 2, and 3, and quizzes 1 through 5 in it. Now we have same students, same ID numbers. We have new information about their finals. Maybe a final project score, a final project letter grade, and their final exam score. And we want this information to be combined with the earlier grades data set. So we want to make sure that the information for Bill lines up for Bill's earlier scores, Helen's, etc., all the way through the list. So to do this, we need to first take this data set that's on screen now, and we need to enter it in SAS. So we can just use a data input data lines to create a new data set called finals, and that's what we'll do in Objective 4.10. Alright, in Objective 4.10 we're to combine the two data sets, grades and finals, into a single SAS data set, all underscore grades. Notice that's one word, so that each of the 6 student records are correctly aligned. Print the resulting SAS data set without observation numbers. So here, if in this SAS session we haven't already created the grades data set, we need to run the data step that does that. So that's why it's repeated here, is data input data lines. If you have it from an earlier point in the same SAS session, you would not need to include it here again. Now, new information to us is data finals. The information does not have to be in the same order as it was above. Okay, so we have ID numbers, and then we have their final project score, final project grade, and their final exam score. So we have all of this information, but now we want to line those up. So again, the student order can be different. In this illustration, it is shown the same. So now then, to combine things, I need to sort dataset grades, the initial one, by name and ID. So that if I had 2 students with the same name, since I've kept things simple here, if I had 2 students named Bill, then I would have Bill with the first ID and Bill with the second ID. We sort the finals data set in the same order. So those must be identical or at least compatible. Then whenever we create a new data set, so we have data, new name, and then we merge the things we want to link side by side. And so what do they have in common then are these key variables that we put in the by statement. They have name and ID in common. Okay, and then we want to just print the results of that here in Objective 4.10. So if from this, I'm going to clear the previous work we've done here and all the lines of title. That's not required, of course, but we'll go back and look at the creation of our data. So I have 6 observations, 10 variables. Finals has 6 observations, 5 variables. Proc sort for each of the data sets, no errors, and then merge all that works. So there's no indication of any error or invalid data or any sort of warning. So when I look at the printed output in Objective 4.10, each of the students, notice the order is different. Bill was the first in the previous data sets, but now everything has been alphabetized. And so that I have scores, all of Bill's information, and now his final project and exam information given here. And so that I can link things up then between the 2 records. Now, if I would have had, say, in the initial data set grades, maybe I have another student in there and that student drops the class. So that if they drop the class, I wouldn't have any finals information for that student. So wherever that student's name appears in here in terms of alphabetical order, it still would appear in the grades. So say it's a name Edward that would come after Dana and before Helen. Edward would have information for as long as he was in the class, and then everything would be blank after that. So that's what would happen if they don't match exactly for the number of rows for those key variables. Now, in Chapter 4 in your book, I would encourage you to read information about what happens if the data aren't sorted. The error codes are highlighted there. Also in Objective 4.11, what if you use set instead of merge? And so you can print the data set and see what the impact of using set instead of merge is. And so that it's pretty obvious if you've picked the wrong one. And likewise, if you used merge instead of set in the first examples we had with fish and fish from Noble County. So in addition to data input data lines and an output statement to create data sets, we have learned now then a set command and a merge command that modify data sets. Notice also again with the merge statement, there is no input, there is no data line statement, and I emphasized that whenever we spoke about the set statement as well. Okay, so not all data steps have an input and data lines statements within it. All of these are regarded data step operations. If you use a merge statement, you should have a by statement as well, and the sort by that those same key variables should be in agreement. There are some exceptions whenever your by statement, if you don't use a by statement here, there are ways where you can get correct output. Most often it's incorrect output or incorrectly combining the data sets. So as we're learning things here, my advice to you is to sort every data set involved in the merge and sort them compatibly and use that compatible by statement then when you merge. Both set statements and merge statements, you can have more than more than two data sets in those statements. So the set command, we saw that it could be used for one or more than one data set. For merge, it's going to be two or more. So you want to make sure then that you sort everything compatibly before you merge all of those. So you could have 5 data sets that you wanted to merge, and that would still work. We use a print statement for now to check the contents of those data sets. That way, whenever we see it, the printed results, we can immediately see if we've combined the data sets correctly or not. Once we get going then with the rest of the analysis, say, well, once I verify that that looks right, you can take the proc print out and then move on to doing the data analysis on the new data sets that you have created by concatenating vertically or by merging side by side. Now on screen I have both the set command and the merge command shown here. So there can be, as I said just a moment ago, there can be more than 2 data sets on each of these statements here. The additional thing you can do is that on a line after the set statements, you can put if-then statements. You can do further variable assignment statements or variable transformations. Likewise, after you merge things and by, you can come in here and you can start creating new variables. So say for grades, if you wanted to start your computation for a final grade in the for the course, you could go ahead and do that. Likewise for fish, if there's some other combination we wanted to add here, we can do that. Okay, so it doesn't just stop with data and set or data, merge, and by. You can add more variable assignments. You can add if-then statements there if that is necessary.